Ancient artifacts that shouldn't exist challenge our timeline of human development. The Antikythera Mechanism, Baghdad Batteries, and precision stone cutting suggest lost advanced knowledge. Today, we explore 5 ancient inventions that modern science cannot explain. Our story begins in 1900, when Greek sponge divers discovered a Roman shipwreck near the island of Antikythera. Among the treasures was a corroded lump of bronze, which sat forgotten in a museum for 2 years. Then, the lump broke apart, revealing a complex assembly of interlocking gears. Dated to around 100 BCE, the device contained at least 37 bronze gears. Nothing of similar complexity would appear for another 1,500 years. This single artifact defied all known history. So what was this ancient computer? It was a portable cosmos. The front dial tracked the sun, moon, and 5 visible planets through the zodiac. The back dials were even more ingenious, using spiral displays to predict solar and lunar eclipses with stunning accuracy. It even tracked the 4-year cycle of the Olympic Games. For decades, its full purpose was a mystery. But in the 21st century, advanced X-ray technology allowed scientists to peer inside. They found the device's instruction manual, thousands of characters of ancient Greek text. Perhaps the most shocking discovery was a piece of technology that shouldn't exist: a differential gear. This brilliant device was used to calculate the phases of the moon. Before this, its invention was credited to the 16th century. The Antikythera Mechanism proves ancient Greek engineers had mastered it over 1,500 years earlier. Digital and physical reconstructions have proven this ancient analog computer worked. It stands as a testament to a lost world of scientific genius, forcing us to ask, what other marvels of engineering have been lost to the depths of time? Imagine a sword so sharp it could slice a falling piece of silk in midair, yet so tough it could bend 90 degrees and spring back perfectly straight. This wasn't a myth from a fantasy novel. It was the terrifying reality for warriors who faced Damascus Steel. For centuries, these blades were the pinnacle of metallurgical artistry, possessing a combination of properties that seemed impossible. They were born from a technique so advanced, its loss around 1750 has left modern scientists baffled. Accounts from the Crusades are filled with tales of these legendary weapons. European knights, clad in heavy armor and wielding thick, brittle iron swords, watched in horror as their own blades were cut in two or shattered against the superior Middle Eastern steel. The famous Sultan Saladin was said to have demonstrated his sword's quality not by cleaving an anvil, but by letting a silk handkerchief fall upon its edge, where it was silently split by its own weight. This was a weapon that combined a hard, razor-sharp edge with a flexible, resilient core, a feat that defied the conventional understanding that a metal could be hard or tough, but never both. The steel's most iconic feature is its distinctive flowing pattern, known as damask, which resembles flowing water. This wasn't a superficial decoration etched onto the surface. It was the outward expression of an incredibly complex internal structure, a visual fingerprint of the blade's extraordinary, almost magical properties. For centuries, the source of this power was a complete mystery. But with the advent of scanning electron microscopes, science has begun to unlock its secrets. In a shocking discovery, researchers found that true Damascus steel contains carbon nanotubes, cylindrical molecules of carbon atoms that are among the strongest materials known to humanity. These nanostructures, along with nanowires of an extremely hard iron carbide called cementite, were perfectly suspended within a softer, more pliable steel matrix. This microscopic composite gave the blades their legendary combination of a durable, razor-sharp edge and the flexibility to absorb impact without breaking. How did ancient smiths, without any knowledge of nanotechnology, create such an advanced material? The process began with a special raw material known as wootz steel, imported in cakes from India. This wootz contained specific impurities, trace elements like vanadium and molybdenum, that we now believe acted as catalysts in the formation of the nanotubes during a meticulous, secret process of heating and hammering. When the trade routes that supplied this unique ore were disrupted in the 18th century, the key ingredient vanished. Without the right material, the smith's recipes no longer worked, and the knowledge, passed down only by word of mouth, faded into history. Despite centuries of attempts, and with all the advantages of modern metallurgy, we have never fully replicated the original process. What is sold today as Damascus steel is typically pattern-welded steel, a technique where different layers are folded together to create a visual pattern. While beautiful, it lacks the internal nanostructure of the authentic crucible steel. The precise combination of raw materials, temperature cycling, and forging techniques remains an elusive, lost formula, a testament to an ancient art that still surpasses our modern understanding. In the heart of Rome stands the Pantheon, crowned by the largest unreinforced concrete dome in the world. Nearly 2,000 years after it was built, it remains perfectly intact, a silent testament to the genius of Roman engineering. Roman concrete structures have survived earthquakes, tsunamis, and centuries of relentless weathering. From harbors battered by the sea to aqueducts and temples, their resilience puts modern concrete to shame. The secret ingredient was volcanic ash from Pozzuoli, near Naples. When mixed with lime and seawater, it triggered a chemical reaction that formed microscopic crystals of a mineral called aluminous tobermorite. These crystals grew within the concrete, filling cracks as they formed and making the structure even stronger over time. In effect, Roman concrete could heal itself. Modern Portland cement, by contrast, begins to crumble within decades. Its rigid structure cannot repair itself, and exposure to salt water or weather accelerates its decay. The environmental impact is just as striking. Roman concrete required less energy to produce and generated far less carbon dioxide than today's cement, making it both greener and more durable. For centuries, the formula for Roman concrete was lost. Only recently have scientists, using modern microscopes and chemical analysis, begun to unlock its secrets, marveling at a technology that still outperforms our own. The lost art of Roman concrete reminds us that sometimes the greatest innovations are buried in the past, waiting to be rediscovered. In the annals of archaeology, some discoveries are so baffling they threaten to rewrite history itself. Unearthed in the 1930s near modern-day Baghdad, a collection of unassuming terracotta jars dating back to the Parthian period around 200 BC presented just such a puzzle. At first glance, they appeared to be simple storage vessels, but a closer look revealed a design so peculiar, so far ahead of its time, that it sparked a century of debate. Could these be ancient electrical devices, predating Alessandro Volta's invention of the battery by a staggering 1,800 years? Each jar, standing only about 5 inches tall, contained a meticulously assembled set of components. A sheet of copper was rolled into a cylinder and placed inside. Suspended in the center of this cylinder, but carefully isolated from it, was an iron rod. The entire arrangement was sealed at the top with a plug of asphalt or bitumen, which held the rod perfectly in place. This specific non-contact arrangement of two different metals is the fundamental design of a simple galvanic cell, the basic building block of a battery. The question was no longer just what they were, but what they were for. Laboratory recreations have confirmed the theory. When these replica jars are filled with a weak acidic liquid, an electrolyte like grape juice or vinegar, which would have been readily available in ancient Mesopotamia, they generate a steady electrical current. Experiments have consistently produced a voltage between 0.8 and 2 volts per jar. While not powerful by modern standards, linking several of these jars together in series could produce a higher, more useful voltage. The artifacts weren't just shaped like batteries, they functioned like them. This astonishing fact opened the door to the most compelling and controversial theory for their use: electroplating. The leading hypothesis suggests these batteries provided the power for gilding, a process of applying a thin layer of gold onto the surface of another, less precious metal like silver. This technique, known as electroplating, would explain how ancient craftsmen could have achieved such impossibly thin and uniform gold plating on delicate jewelry and ornaments without modern technology. It would have been a cleaner, more precise, and safer alternative to the toxic mercury-based fire gilding methods also used in the ancient world. If true, it implies a sophisticated understanding of chemistry and electricity that historians never thought possible for the era. However, the case is far from closed. Skeptics rightly point out that no definitively electroplated artifacts have been found in direct archaeological context with the batteries. Alternative theories propose that the jars were simply for storing sacred scrolls, with the metal components intended to protect the parchment from decay, their electrical properties being purely coincidental, Another fringe idea suggests a medicinal purpose, where the mild electrical charge could have been used for pain relief, a primitive form of electrotherapy. Despite the debate, the Baghdad Battery remains a profound enigma. It stands as physical evidence that our ancestors may have harnessed scientific principles we thought were discovered only centuries ago. Whether a power source for intricate artistry, a sacred vessel, or something else entirely, this small clay jar forces us to question the linear progression of history and wonder what other secrets of lost Mesopotamian science still lie buried beneath the sand. In the high plains of Bolivia, the ruins of Puma Punku rise from the earth. Massive stone blocks, some weighing over 100 tons, scattered like a forgotten puzzle. These stones are not just enormous, they are cut and shaped with a precision that defies belief. Some blocks are carved with perfectly straight edges and right angles, their surfaces as smooth as if machined. The seams between stones are so tight that not even a razor blade can slip between them. Tool marks are almost non-existent, and the shapes, complex interlocking forms and deep grooves, suggest techniques far beyond what Bronze Age tools should allow. Thousands of miles away, the Egyptian pyramids stand as another testament to ancient precision. The limestone blocks are aligned with such accuracy that the Great Pyramid's base deviates less than an inch over hundreds of feet. The joints between stones are so fine that after thousands of years, they remain nearly invisible. The alignment of the pyramids to true north is more accurate than most modern buildings. Ancient builders had only copper chisels, stone hammers, and simple tools. Yet their work rivals what we achieve today with diamond-tipped saws and lasers. Modern engineers have tried to replicate these feats. Even with advanced machinery, they struggle to match the speed and accuracy of the ancients. Some attempts have failed entirely, leaving experts baffled. Scientific theories abound, ranging from lost technologies and abrasive sand cutting to the use of simple levers and manpower. Yet none fully explain the scale, speed, and precision achieved. The mystery endures. What knowledge did the ancients possess that we have lost? The silent stones of Puma Punku and the pyramids keep their secrets, challenging us to rethink the limits of ancient science. Across centuries and continents, the Antikythera Mechanism, Damascus Steel, Roman concrete, the Baghdad Batteries, and precision stone cutting all defy our expectations of what ancient civilizations could achieve. Each invention is a puzzle piece, hinting at lost knowledge and scientific mastery that challenges the very timeline of human progress. As scientists and explorers continue to investigate these mysteries, we are reminded that history is far from settled and that the past may hold secrets we are only beginning to rediscover. What other wonders lie buried waiting to be found? Stay curious and join us as we continue to explore history's greatest enigmas. Subscribe for more journeys into the unknown.